Now let's look at conversion of galvanometer to ammeter. Basically, the electrical symbol for galvanometer is a circular shape with an arrow on it. So this is the electrical symbol for galvanometer. So the one we have here is a galvanometer at what? Full deflection. That means this arrow is deflected to its maximum point. So let's look at how to convert this current indicating device or this moving coil device, how to convert it to an actual ammeter. Now, you know that there is a amount of current that will enter the galvanometer that will drive it to its full deflection. That current, we label it as what? I subscript what G, that's galvanometer current. And that's what we have here, galvanometer current. That's the current that will drive this galvanometer to full scale deflection. Now, depending on the amount of current that enters this galvanometer, the current might be, which usually very small, very small current, say in milliamps, something like 10 milliamps. So that means if you calibrate this galvanometer here based on this maximum current that it can take, if you calibrate it, that means this galvanometer cannot measure a current beyond 10 milliamps. So for you, and you know, the duty of an ammeter is to measure a wide range of current. So how do we convert this galvanometer to an ammeter such that it can measure a wide range of current, not just a minute current? So to convert a galvanometer to an ammeter, or we say to extend the range or the range of the measuring capacity of the ammeter, what we do, we connect a resistor in parallel to the galvanometer. You see the resistor here, R, capital letter R, or you call it shunt. Shunt simply means a resistor that is connected in parallel with another device. So to convert a galvanometer to an ammeter, you connect a shunt, or you say connect a resistor in parallel to the galvanometer. So now when you do this connection now, we have galvanometer current, which is I subscript G. We have galvanometer resistance or internal resistance, which is small letter R. Now, this current that comes in is the current you want to measure. Now, when this current comes in, this current will be divided into two. Part of it will go to the galvanometer, while part of it will go to the external resistor. You know, in a parallel connection, current is usually divided. However, in a parallel connection, voltage remains the same across each network on the parallel connection. So I here, without a subscript, is the actual current that we want to measure. Is the range of current that we want our ammeter to measure. So when this current comes in here, it will be divided into two. Part of it will go to the galvanometer, which is I subscript G, and then part of it will go to the resistor, and we label that one what? I minus I subscript G. You know, this current minus galvanometer current will give you the one that will enter the resistor. So now, for us to know the range, to determine the range of current that, or to design the range of current you want the galvanometer to measure, that's it being an ammeter now, is for us to know the the value of resistor will depend on the value of the resistor we connect to it in parallel. So now let's do this. Now, potential difference PD, potential difference across galvanometer equals to, you recall that potential difference or voltage equals to what? Current times what? Resistance. Current times resistance. Or voltage equals to what? Current times resistance from Ohm's law. So potential difference across galvanometer, that's the potential difference across this galvanometer, will be given as what? Galvanometer current, which is Ig, times the internal resistance of that galvanometer times R. And then the potential difference across shunt resistor R, across the parallel resistor R, potential difference across it can be measured as the current through this resistor is what? I minus Ig. I minus Ig times what? The value of the resistor, which is R. That will give you the potential difference across the shunt resistor. So you now recall, since this is a parallel connection, that's the resistor is in parallel with the galvanometer. And you recall in our basic knowledge of parallel connection that the voltage across each branch in a parallel connection is the same. That means the voltage or potential difference across this galvanometer is the same as the potential difference across this resistor. So it is safe for us to now say that potential difference across galvanometer is equal to what? Potential difference across what? Shunt, or across R. So when we do that, we now say that the potential difference across the galvanometer is represented by what? I subscript G times internal resistance equals to what? Potential difference across R is what? I minus, that's the total current you want to measure, minus Ig times what? The external resistor R, the external resistance R. Then we make R the subject of the formula, because this R here is a determining factor. It's a determining factor that will determine the range of current our galvanometer, our ammeter can measure. So we make R the subject by dividing both sides by I minus I subscript G. You have I subscript G times R divided by I minus I subscript G. So this relation here on this bottom, or the one here, is very, very important when doing calculations based on galvanometer as an ammeter. Thank you.